CLANG by Ernst Chladni, Sound Experiments. Written by Dancy Pattison, illustrated by Peter Willis. CLANG. In the year 1806, Ernest Florenz Friedrich Chlanbi knocked on the door of his house in Wittenberg, Germany, climbed into his spacious carriage, and left town. It would be 4 years before he returned. Chladni was a scientist who studied sound. Unlike many scientists of the time, Chladni didn't work for a university. Instead, he traveled because he earned money by entertaining people with his sound experiments. Chladni traveled in the Netherlands and Brussels for 2 years. In 1808, Chladni moved on to Paris, France. There he met with French scientists who admired his work. The French scientists especially liked his 1802 book, Die Akustik, or The Acoustics. The book explained the science of sound and sound waves. However, the book was written in Chladni's native German language. French scientists encouraged Chladni to translate the book into French. But Chladni had 2 problems. First, he needed enough money to live on while he did his work. Second, he needed someone to make sure his French was correct. Chladni's friends, the French scientists, decided to help with both problems. At 7 p.m. on Tuesday evening in February 1809, a carriage pulled up to the Tuileries Paris in Paris, France. The Tuileries Palace in Paris, France. This was the home of the notorious Napoleon Bonaparte, Emperor of the French people. Perhaps Emperor Bonaparte would help fund Chladni's book. When Chladni entered, Napoleon welcomed him. He introduced Chladni to his wife, his mother, his uncle, and his assistant. Quickly, Chladni set up his equipment. First, he entertained them by playing the clavicylinder, a musical instrument he had invented. It looked something like a piano, but pianos created sound by hitting wires of different lengths. Instead, the clavicylinder made sound by rotating a glass cylinder. When he pushed a key on the keyboard, a bar moved forward to touch the cylinder. The bar vibrated and made a sound. Chladni played some musical pieces on the clavicylinder. It pleased everyone. Clang! Napoleon asked if he could play the clavicylinder. Chladni agreed, but he suggested that it should be played softly because of the glass cylinder. Instead, Napoleon banged on the keyboard. Fortunately, the clavicylinder did not break. Napoleon whispered to one of the French scientists, "Could I see inside of the clavicylinder?" Chladni overheard the emperor's question. He answered, "The instrument is still a secret." He wouldn't allow anyone to look inside because he was afraid someone might steal his invention. Next, Chladni planned to demonstrate sound experiments. Sound waves are hard to study because they can't be seen. Earlier in his career, Chladni studied how sound was created by vibrating strings of a musical instrument. Next, he studied how fast sound waves moved through the air of a pipe organ. His most famous experiment, though, were how sound traveled through solids such as metal or glass. Chladni started his sound experiment for the emperor by centering a brass plate onto a single support. Sand was sprinkled over the plate's surface. He used a violin bow and to stroke the side of the brass plate. As the sound waves traveled through the plate, it made the brass vibrate. The vibrations pushed the sand around. Sand gathered in places where brass plates was not vibrating. Very low sounds made simple shapes. Very high sounds made complex shapes. The audience was fascinated by the sound waves, the sound wave figures in the sand. Napoleon knew that mathematics can explain science. He asked Cialdini to explain the mathematics of how sound waves travel through solids. While Cialdini understood some of it, he didn't have the full mathematical explanation. The next morning, Napoleon sent Cialdini a gift of 6,000 francs to translate his book into French. It was enough for Cialdini to live comfortably for several years while he worked on the French version of his book. The French language was difficult for Cialdini to write about sound. For example, in German, he could write Schall, ring out or peal, Klang, which means clang or clink, and ton, resound. But French had only one word for sound, son. French scientists helped Cialdini with the language. His new book, Traité d'acoustics, or Treatment of Acoustics, was published in French in November 1809. In the opening, Cialdini wrote this declaration. Science historians say Cialdini's book was revolutionary. It created a new field of scientific study, the study of sound or acoustics. What is sound? Let's say that you stretch a rubber band across a box. When you pluck the rubber band, you'll hear a sound. Notice that the rubber band does not make the sound. Instead, it's made when the rubber band vibrates because you plucked it. The vibrations create waves in the air. The human ear picks up the waves and interprets them as sound. When Cialdini studied sound, he studied how vibrations could be made by making different things vibrate. He studied vibrating columns of air by studying pipe organs. He studied vibrating wires by looking at musical instruments such as a guitar or violin. Finally, he studied vibrating solids by studying vibrations of metal plates or glass. Ernst Cialdini, the father of acoustics. Ernst Florenz Frederick Cialdini was a German scientist and entrepreneur. He used scientific experiments and music to entertain and teach people across Europe. His sound experiments brought him fame. In 1802, he published the Acoustics in his native language, German. Friends and fellow scientists in Paris asked him to translate the book into French. Cialdini wasn't like many scientists of the time, though. He didn't work for a university, which meant he needed money from other sources. In February 1806, scientists introduced Cialdini to Emperor Napoleon. The emperor's support meant he could spend the time needed to finish his French book, Treatment of Acoustics, which earned him the title, the father of acoustics. Scientists have always cooperated across international boundaries and often progress only happens when this type of cooperation occurs. The math of sound. After talking with Cialdini, Emperor Napoleon also set up a prize of 3,000 francs for whomever could write a mathematical theory of sound waves. The prize was won in 1816 by French mathematician Sophie Germain, the first woman to win a prize from the Paris Academy of Sciences. The end.